Hello and welcome to some physics revision.
Whoa.
That's right, it's the return. And today in this series we're doing mechanics,
Materials,
waves and
WAHEY.
you see the pun there because this is WAHEY Productions.
Very
Loving
productive.
that. Wow. Part 1 is mechanics mechanics part 1. When things are peaceful and still. Da, 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 da.
I'm not a part of this.
Right. Connor.
Moving on.
Kicking off, please, Mr. Connor Durkin, with vectors and scalars.
Right, vectors and scalars are two topics you should not get mixed up. Vectors simply have magnitude and direction, so, a bit sort of more complicated than scalars, which only have magnitude. An example of a scalar is speed. The speed of a car, for instance, only tells you how fast the car is going, whereas the velocity tells you how fast and in which direction.
Other examples are distance and displacement. Force and acceleration are both vectors and so can be represented by an arrow in the appropriate direction, with length proportional to the magnitude. If more than one vector is present, you can find the resultant vector, which will tell you the overall what will happen. For example, Connor?
I don't know, probably, well, later on you'll come on to freefall motion and speeding and parachuting. Yeah, never mind.
Because the example we're using AQA think they are funny, frankly, it seems that a requirement of the spec is to be able to add vectors by scale drawings, diagrams, whatever
Same
you
thing.
want to call it. Yes, Connor?
Mostly.
Note.
Mine, that in reality it isn't a reliable way of working out anything other than maybe the length of your hair, which is a bit of an odd example to be honest,
But you do need to know how to do it here. Yeah. So, you simply take the vector that they give you and line the ends up so that the arrow is continuous. So the arrows are pointing the same way along the lines as shown.
Indeed. Then simply draw a line from the start point to the end and measure the angle and length.
Now, assuming you select the correct angle, the rest is as simple as using a ruler and a protractor.
We're all doomed.
Yes, we are, Connor.
What a protractor.
If you want to measure the vectors properly, then you can use the wonders that is maths.
Oh, I thought this was physics.
Right every time, sort of.
Now, AQA thought using a ruler was so hard that they will only ask you, in addition, to mathematically work out the resultant vector with our good old chum Pythagoras.
Oh, I love our good old chum Pythagoras.
6,000 years old and still teaching me stuff.
Yes, or you could use Sokotoa.
Silly old Hitler couldn't advance his troops over Africa.
For those who are unfamiliar with Sokotoa, it's simply a bit of trigonometry. Please revise. And it truly is as simple, Connor, as...
A, B, C...
Oh, I love it. I love our new visual aid. Vectors, it's already resolved.
Michael Jackson scares me.
Just kidding. Now, there are some questions, most questions, where you are given a resultant force and you need to find the components. Well, lucky for you, you can now use the WAHEY Productions Triangle of Truth. Ta-da!
Okay, you can't claim that it's pretty much trigonometry.
Yes, I can, and yes, I will. All it is, I admit, is a rearranged Sokotoa, but still, it's handy to remember. Now, onto equilibrium, which occurs when, Connor?
When the resultant force acting on an object is zero, so all forces are balanced.
I know, that's what it says on the slide, Connor. To work this out, you might want to give yourself some kind of axis, so you can resolve the forces in the horizontal and vertical components.
The axis of evil.
If an object is on a hill, for example, you might want the x-axis to be the gradient of the hill, and then you would only need to resolve the weight, which always acts straight down. And now a Durkin don't do.
Okay then.
Go, Connor.
Today's Durkin don't do is do not under any circumstance get mass and weight confused. And a will tip, which is a...
Nice name, obviously,
yes.
Is to always draw your force diagrams as accurately as you can if asked. In this case, size most certainly does matter.
Overcompensate much?
Stop it! Stop crying. I know you can see moments. I know everyone hates moments, but you have to get this fear out of your heads.
I like moments.
Seriously.
Yeah.
Connor, what are moments?
Moments are not forces. They are moments defined as the force multiplied by the perpendicular distance from the line of action of the force to the pivot or fulcrum.
All that means is it is the thing describing the object's turniness.
That's a fantastic definition.
And you must remember that for equilibrium, the sum of the clockwise moments must equal the sum of the anti-clockwise moments.
Boom.
Boom! This is known as the principle of moments because this is in charge of all the moment pupils. And also, it's the key to the foundations of moments on bodies at equilibrium.
That was a mouthful. So, to work out a moment problem, you just remember that Just remember that, rather, and the definition, and voila, you have yourself an answer. Hopefully.
I like your little bit of français there. Should we give them an example, Connor? I think we should. When doing a moment question, it is completely up to you where you put your pivot.
Check out that diagram.
I know, I made it with a bounce.
Which way is going to go? Which way?
Just bear in mind that, oh no, I was meant to talk with that. Just bear in mind that the pivot, the forces can be ignored as the perpendicular distance will be 0, and so 0 times anything times 0 is 0, so there are no moments. This idea can be used if you have two unknowns to find one of them, and then the other.
Okay then, linked to this, by the way, are the centre of mass. As a definition of a centre of mass is the point where a single force on the body has no turning effect. So I guess you could call it the natural pivot.
Or pivot naturel.
En français.
Which is why when you place an object on a pivot on their centre of mass, they're balanced.
I can do physics. Yeah.
Yay.
Ooh.
Moving swiftly on.
When the slide allows us.
Yes. Very quickly, a couple is a pair of equal and opposite forces acting on a body, but not along the same line.
The moment of a couple is sometimes referred to as a tour.
Why are you telling me this?
I hear you cry. Well, because there is a cheat. Because in this case, the total moment is just the force multiplied by the perpendicular distance between the two lines of actions of the forces.
Wow, that is simple, Connor.
Yeah, okay.
I know, you are welcome for that hint. I'm here all week.
And me, maybe? And me, as it says on the slide. Nice spelling.
Yeah, be quiet now. Now, be aware that you need to know a few little extra bits, which lots of teachers neglect. So here they are.
This is the best picture ever. Wait for it.
Go. Stable and unstable equilibrium. Basically, stable equilibrium is where if you displace something and release it, it will return to its equilibrium position. Like a sheep hanging, if you pull it to the side and let go, it will swing a little bit and eventually remain in its equilibrium position. Yeah. If, though, something is in unstable equilibrium, then this isn't the case. Like a plank balanced on something.
Oh, no shit.
If you push it into a unstable thing, it will fall off and you can't put it back on its equilibrium.
Indeed.
Because it's killed someone on the ground.
Oh.
What is tilting and toppling, Connor?
An object is tilting if it will return back to its original position, but if the line of action of the force passes the pivot, so it goes beyond the pivot or the base at some points, then it will topple. On a slope, this will happen if the line of action of the weight is outside the base. There we go. Again, the pivot.
Yes. So, yeah, basically the centre of mass is very important there. Free body force diagrams just show the forces acting the object. And don't forget the force counterbalancing the weight. So
resistance force.
Yeah, resistance in the case of
the ground.
Weight. And that's it for part 1, mechanics. See, it was really quick, it was really simple, we loved it. We liked it, didn't we, Connor? Yes, we did. Yes, we did.
Yes,
we loved it.
I
Right,
did.
thank you for watching.
I'm
glad you enjoyed it.
Help.
Please comment, subscribe and like and everything. All that shizzle shebang. Shebang.
Yes, do that and please leave me alone.
Thank you for listening. All seriousness. Bye.
Bye-bye.